Hi, I'm Chris Teutsch, Forage Extension Specialist at the University of Kentucky's Research and Education Center located in Princeton, Kentucky. I'd like to draw attention to my co-authors, Lindsay Sparks. Lindsay was an undergraduate student from the University of Tennessee at Martin, and Lindsay was an intern here at the research station this last summer, and this is her project that we're going to be presenting the results for today. My second co-author is Edwin Ritchey. Edwin is our soil scientist here at the research station in Princeton. The title of our poster is Impact of Fertilizer Type, Seed Coating, and Duration of Exposure on the Germination of Red Clover Seed. As everyone knows, clover is an important part of grassland ecosystems in the transition zone. In order to maintain clover in pastures, we often overseed clover in late winter or early spring. And commonly, this is done by mixing the clover seed with fertilizer and broadcasting it onto the pastures. So the objective of today's study was to evaluate the impact of two fertilizer types and the duration of exposure on the germination of raw and coated red clover seed. Our experimental design was a random complete block with 4 replications. We had 2 fertilizer types, muriate of potash and blended fertilizer. We chose muriate of potash because it has a relatively high salt index. We hypothesized because it has a high salt index that it would damage the seed more than a blended fertilizer. We chose a 19-19-19 blended fertilizer because that's commonly used to top dress pastures in the transition zone. We mixed these 2 fertilizer types with raw or coated red clover seed, and we allowed that seed and fertilizer mixture to be combined from anywhere from 0 to 28 days. We stored them under ambient temperature and humidity conditions in a tobacco barn. We then germinated that seed after it was extracted from that seed fertilizer mixture in a petri dish. And we did counts on 3 and 7 days. We used regression analysis to analyze our data, and we used a program called SigmaPlot 14.0 to generate the graphs and conduct the analyses. So I want to take just a minute and share with you some of our results. If you look in the middle, we've got 4 graphs. The top 2 graphs are from trial 1, and then we repeated the experiment, and that's what we call trial 2. Same experiment exactly, just repeated to make sure we'll get similar results. So the graphs, if we look at the top 2 graphs, the graph on the left-hand side is the impact of potash on germination rate. We have germination rate on the y-axis, and we have length of exposure on the x-axis from 0 to 28 days. The second graph is the same graph, germination on the y-axis, duration of exposure on the x-axis, except it's for the blended fertilizer. So potash and then blended fertilizer. The second set of graphs are set up in exactly the same way, only for trial 2. So let me just share a few key findings with you today. What we found was that when we exposed that seed to muriate of potash, it resulted in a linear decline in seed germination. And that's what we're seeing here, this linear decline in seed germination. The rate of decline was greater for coated seed than for uncoated seed. And that happened in both trial 1 and trial 2. When we exposed that seed to blended fertilizer, we had a reduction in germination rate, but in a quadratic manner for the coated seed only, in a linear manner for the uncoated seed. So these are blended fertilizer here and here, and this is the impact of that blended fertilizer on seed germination rate for uncoated or raw seed, and this is the impact of the coated on the coated seed. We can see that the response was different because it was a quadratic response, but not only that, the rate of decline for the coated seed was much greater than that compared with the raw seed. And that happened in both experiments, 1 and 2. After 20 days of exposure to the blended fertilizer, the germination rates for the coated and raw seed respectively was 0 and 60%. So there was a significant difference due to seed coating. So the blended fertilizer was more hygroscopic, so that means it picked up more moisture from the air, and by the time the storage period was over, the blended fertilizer with the seed was almost like a slurry rather than a dry product. The other interesting part was that the nature of the coating on the seed was hygroscopic, so that means it draws moisture in, and that's good when that seed's in the soil and you want to draw moisture in to get that seed to germinate. But it's kind of bad when it's mixed with fertilizer, especially if the relative humidity is high in the air, because it's going to draw that moisture and that salt into the seed and cause greater damage to that seed in terms of lower germination rates. All right, so those are the key findings of the experiment. Be happy to answer any questions. If you have any, our contact information is here at the bottom of the poster. So thanks again for taking the time to watch our poster, and if you have any questions, please contact us.